Ever wondered what really happens when you click your mouse, for example, to open up a folder or launch a program?
Hello, my name is Roberto, and today we're going to explore how a computer works. And we'll try to do that in a super easy way, starting from a simple mouse click, a mouse like this one, and we'll try to understand how from a mouse click we can move into a performed action step by step. Before we do that,
subscribe to our channel!
let's go. It all starts with a mouse click. When we press our mouse button, we are sending a signal that goes from our mouse to the computer. Think of this signal as a small pulse of energy, a tiny spark down a wire. We'll do this example with the mouse, but actually works for any kind of device. If you think of your keyboard, your joystick, whenever you press a button, the action is the same. This electric signal is a bit like the electricity that powers your home, but on a much smaller scale. In computers, this signal is usually just a few volts, not enough to power a light bulb, but perfect for sending information. Consider that this signal can be either wired through cables or wireless via electromagnetic waves. But we're not going to go into those details because we want to keep this video simple. Once this signal reaches your computer, it goes straight to the CPU, which is the big brain of your computer. You can think of the CPU like the manager of a busy office. Once it receives the signal, it decides what needs to be done next.
But the point is, how does my computer know the action that needs to be performed? For example, when I click my mouse button, how does it know that I actually clicked the left or right mouse button? Well, the computer speaks a language that is called the binary language, which is made of zeros and ones. Each 0 and 1 is called a bit. In the world of computers, everything from the text you write to the images you see on the monitor is made up of these bits. Now you may ask, hey Roberto, but how can I
Send out several pieces of information if I only have two values, 1 and 0. Well, it turns out that we can work with a combination of bits, making up the so-called bit strings. And in this case, the number of all possible combinations increases. Imagine you have a row of light switches. Each switch can be either off, which represents a 0, or on, which represents a 1. By flipping the switches in different patterns, you can create different outcomes. For example, 001 or 110, those are two different sets of bits. The longer the strings, the higher the number of possible combinations. That's when we're here talking about 32 bits, 64 bits, that's exactly what it is.
Okay, now that our brain, our CPU, has received all of these zeros and ones,
it starts processing that information. Consider that a CPU is filled with billions of these tiny switches, and they are called transistors. These switches rapidly turn on and off, following the instructions encoded in binary. Think of the CPU like a huge team of workers in a warehouse. Each worker has a simple task, like flipping a switch or moving a lever. By working together at the speed of light, they can process any request almost instantly.
all clear so far?
So don't forget to like and subscribe. Let's move on.
Okay, so now the CPU has the information, but in order for it to handle your request, it needs some workspace, so some place where to put that information and to work on that. That's where the RAM comes in. Think of the RAM, random access
Memory, like a big workbench where the CPU lays out all the tools and the materials it needs to work on. The bigger the workbench, the more tasks the CPU can handle at once.
That's what the RAM does for your computer. It gives the CPU the space required to work quickly and effectively.
And that's also the reason why for heavy processing we need a lot of RAM memory.
But what if the CPU needs information that is not currently in the RAM memory? That is when it goes to the hard drive or SSD
where all of your data is stored. So for example, when you save an image on your phone or your computer, you're not saving it in the RAM memory, but you're saving it on the hard drive. That information gets pulled only when the CPU needs it. The hard drive is like a library filled of books. Each book contains information about your files, photos, or programs. When you click to open a file, the CPU sends a request to the hard drive, just like asking a librarian to fetch a book. The hard drive quickly finds the information and hands it over to the CPU. If you have a solid-state disk, SSD, it's like having a librarian which is super fast and gets the information in an instant.
But how do we display information? So when the CPU has all the information needed,
it sends instructions to the GPU or graphics processing unit. Imagine an artist working on a blank canvas, turning ideas into a beautiful picture. The GPU does the same thing, but instead of paint, it uses pixels, the tiny dots that make up the images on your screen. Each pixel in your monitor is colored using a combination of RGB channels, red, green, blue, each one described by a specific series of bits. The GPU is like an artist that is specialized in creating visuals. It takes the raw data and displays that in form of text, images, videos, or anything else that gets displayed on your monitor.
So just to recap,
We have a signal that is sent from our hardware, for example a mouse click, that goes straight to the CPU. The CPU needs some information which is not currently in the RAM memory, so it pulls that information from the hard drive and it sets that into the RAM memory. So now the CPU has the workbench ready to start working on the information. The information, which is being processed by the CPU, is then ready to be displayed. So finally the GPU sends the completed image to your monitor, where it's displayed as the final result. Consider that all of these steps, so from the mouse click to the GPU rendering, all happens in a blink of an eye. All the hardware components that we mentioned before, so the CPU, the GPU, the RAM memory, those are all isolated components. And in order to work together, we need the so-called motherboard. The motherboard is the true backbone of your computer, holding everything together and making sure that all the isolated components can communicate to each other. Think of the motherboard like a big train station. It has tracks that connect different parts of the city, like the CPU, RAM, and the hard drive. Just like a train station, it allows passengers to travel between places. The motherboard allows data and electrical signals to move between different parts of your computer. Without the motherboard, all the components would be isolated and nothing would work together.
here it is. This is how your computer turns
A simple mouse click into an action. From the electrical signals through binary processing to the final image on your screen, it's a complex process that happens in milliseconds. So the next time you click on your mouse, remember all the incredible steps happening inside your computer.
Thank you for joining this journey inside a computer. Be sure to like, comment, and subscribe for more easy explanations on how technology works. See you in the next video.